Okay, there's one last type of transformation. And we kind of do it by itself. We don't do it with the other transformations. Okay, so it's kind of done by itself. And it's actually a flip, but it's a diagonal flip. So the line, this is the line y equals x. Okay. That means every point on this line has the same x value and y value. So this is 0, 0. This is 1, 1. This is 2, 2. This is -1, -1. -2, -2. So an inverse would be a flip over this line. So you kind of have to tilt your head 45 degrees. So like if I was say to flip this shape, kind of tilt your head 45 degrees, what would the inverse look like? It would be like this, because you flip it over that line. Okay? So that's what we mean when we talk about inverses. And what happens in math notation when we do an inverse? It's very simple. The x's and y's switch. So y, its new point will be yx. So the inverse of the point -2, 1, 1, -2. The inverse of the point 0, 0, 0, 0, because you flip, it's the same number. The inverse of 7, 10, 10, 7. Okay? So how do we find inverses? Well, we can graph inverses. We can also find the inverses of different types of functions, or sorry, functions in different forms. So here's a function called f, and its form is in a set of ordered pairs. What would be its inverse? You take all the points and reverse them. So the inverse of this function would be 2, 1, 4, 2, 6, 3, and 8, 4. This is the notation for the inverse. It looks like an exponent, but it's not. Okay? So we wouldn't say f to the -1. We would say f inverse. Because obviously we're not doing an exponent in this question. So that's how we flip a function that's shown as a set of ordered pairs. How do we take the take the inverse of a function that's represented as a set of ordered pairs? What about if it's an equation? Well, we got to do algebra. What's f of x the same as? I always told you. Y. So that's the first thing we're going to do. Is we're going to replace the f of x, or whatever letter is used, usually it's f of x, we're going to replace it with y. How do I take the inverse? Switch the x and y. So what does the equation look like after I do that? And now you have to solve for y. Because remember, in equations, in these type of equations, we always solve for y. So I have to take the 1 over to the other side. So I get x minus 1 equals 2y. And then the last step to get y by itself is divide both sides by 2. X minus 1 divided by 2. That's the inverse equation. And it kind of makes sense if you think about it. The original equation, we doubled and added 1. Working backwards, we would subtract 1 and divide 2, which is exactly what we did. However, you have to show that it's a function, an inverse function. So we've got to do one final step, and this is just a notation step. Like so. You replace the y with f inverse. This is the original, or this is the original. This is your inverse. Okay. So like I said just earlier, it makes sense that if in the original function we're multiplying by 2, then adding 1, okay, then we would just reverse it. We would take the inverse value and subtract 1, then divide 2. So that's how we find the inverse of a function in equation form. What about graph form? So we're going to find the inverse of this function graphically, and we're also going to find it algebraically. So if I were to do it graphically, here's the original function. This is x squared minus 1. You guys should all be familiar with this. It's taking x squared and moving it down 1. So your vertex is there, and you go 1 across, 1 up, and then 2 across, 4 up. That's your original. Okay. So graphically, the original and we get, I always plot them from left to right, negative 2, 4, negative 1, 1, sorry, not negative 4, negative 2, 3. Because we moved it and we shifted it a bit. Negative 2, 3, negative 1, 0, 0, negative 1, 1, 0, and 2, 3. Well, the inverse function is reverse. So 3, 2, negative 2, pardon me. Negative 1, 0. 1, 0. 0, 1. 3, 2. Plot them, connect them as you go, and it's going to be a curve. So we've got 3, negative 2 here. Then we've got negative 1, 2. Wait a minute. Whoa, what did I do? Should be 0, negative 1. Did I do that? Sorry. I don't know what I was thinking there. 0, negative 1. So 0, negative 1 goes here, connect. And then 1. Oh my God. That's careless errors. 0, negative 1 becomes negative 1, 0. 1, 0 becomes 0, 1. So notice I'm connecting. And 2, 3 becomes 3, 2. So you can see that's the inverse. And remember what I said, what line it's reflected over? It's reflected over the diagonal line. y equals x. And it makes sense because if you tilt your head 45 degrees, if you flip the red over that black line, you'll get the blue. So that's doing it graphically. Doing it algebraically, well, we take the equation, instead of g of x, we write y. Now what do? Reverse the x and y's. So this is going to become x equals y squared minus 1. Solve for y. So we've got to bring the negative 1 over to the left. So we get x plus 1 equals y squared. Almost. Not just square root. Because I'm solving for y. I'm getting y by itself. Not just the positive square root. You have to take the positive and the negative square root. So therefore, this is going to be the equation of the inverse. And then, of course, the final step would be to change that y to g inverse x, except we don't this time. You tell me, look at the graph of the blue one. G inverse means it's a function, right? Is the blue one a function? Why not? Doesn't pass the vertical line test. It's not a function. I can draw a vertical line through more than one point. So I can't put G inverse X. I can't put G inverse X because this is not a function. That's why I can't do it. This is a common question that's asked, which is why I've added it. So right now, if we take the inverse of x squared minus 1, its inverse is not a function. We found the inverse, but it's not a function. Okay? What could I have done to the original red? And when I say what could I have done, and if it asks, how do we restrict the domain? That means, what can I cut off the red so that if I take its inverse, it would be a function? Look at the red. Right now, if I flip it over y equals x, it's not a function. Cut off part of this for me so that if you did inverse it, it would be a function. Half of it, exactly. I'm going to cut off this half. Because if I take the inverse of this, I just get this, which is a function. So how do we restrict it? How do we say we restrict it? Well, I cut off everything from negative infinity to 0, didn't I? So that means, how are we going to restrict it? Well, I'm going to start the red one at 0 and go to positive infinity. That's how I restrict it. Is I cut off the left side, wrote the domain of the right side. There's another answer. I could have cut off the right side. I could have done this. I said, okay, I'm going to leave this part, but I'm going to cut off this part. So how did I restrict it? I left this. What's the domain of this? Negative infinity to 0. Both of those are possible answers. You don't have to write both, only one. But that's how you restrict a domain, is cut off half of the original. The left half or the right half. Excellent. Okay. So let's just look at a couple of questions. I'm given two functions. I'm asked if one is the inverse of the other. And you have to prove it. What would you do? How could I prove that these are inverses? Take the inverse of this and see if you get this. Or take the inverse of this and see if you get this. Doesn't matter. So let's take the inverse. So f of x becomes y. Reverse the x and y. And then solve for y. So move the -1 over. I get x plus 1 equals 2y. Divide both sides by 2, and I get x plus 1 over 2 equals y, which does equal gx. They are inverses. You don't have to check both ways, because if you take the inverse and get the other function, it's got to work the other way. Has to. Okay. Here's one of these restriction ones again. We've got a parabola. How do I know it's a parabola? Because it's got x squared. But it's a parabola that's been shifted 1 to the right. So its graph, I'm just going to do a quick sketch of its graph. This parabola is going to look like this. Where I know this is the point 1, 0. And I know that if I take the inverse of any parabola, no matter where it is, its inverse will never be a function. So I have to cut off part of the parabola. And how much did we say to cut off? Half of it. What half you cut off is up to you, because both are right. So if I say cut off the left, what's left of the domain now? No, I've cut that off. 0 to infinity. If I cut the right side off, then it would be negative infinity to 0. Either or. You do not have to write both. One, two, good catch. Okay. Let's just sketch a couple and look at some other problems. So we're asked to do a few things for these next two examples. We're given the original function in red. We're asked to sketch the graph of the inverse and name any invariant points. We're supposed to find this domain and range of the original. State the domain and range. No, that doesn't make sense. I never noticed that before. State the domain and range of the function and its inverse. Change that. That makes more sense. Or you could say relation. Relation and function being the same thing. Okay, so let's graph. Well, there's two ways you could graph it. You could use the graph, which can be a little bit difficult if you have a little trouble seeing things visually at an angle. Like I could do this. I know for me personally, it's difficult. Remember, it's flipped over that line. So you could kind of look at that line and say, okay, I'm going to take this and I'm going to flip it over. What does it look like? I have a little trouble seeing that. But what it would look like if you did it just the graph way is oh, see, I can't even. It would look like that. But I have trouble seeing that. Okay? Especially if it's a more complex graph. Like, so I'm going to get rid of this. Oh yeah, I just brought those back. Wait. And I'm going to do mapping notation. So, pick some points on the original. Well, I could probably pick a point here, here, and here. That would be good. I mean, you could have picked a point down here, you could have picked a point there. So I picked the points -2, 0, 1, 3, and 4, 3. When we do an inverse using mapping notation, switch the x and y's. So it becomes 0, -2, 3, 1, and 4, 3. 3, 4, pardon me. Thank you. I know it's brutal. It's terrible. It's awful. Okay, 0, -2. And then we're going to connect as we go. 0, -2, 3, 1, and it's connected by a segment, straight segment. And then 3, 4, connected by a segment, and then there's arrows on the end. So you see, I actually got the same thing as when I had to do it by graph. Thanks. Are there any invariant points? Are there any points that did not move when we inverted them?
No.
Really? That point right there. How do you find the invariant points? Look on the slanted line. Any points that are on the slanted line. So that's the point. Invariant points, in this case, I'll just write it up here, would be 3, 3. What are the domain and range of the original? It's pretty straightforward. Yeah, for both. Sorry, not for both. The range is not negative infinity to infinity. Negative infinity to 3. What is the domain and range of the inverse? What's the domain of the purple one? And the range? Notice anything? The domain of the, yeah. And that makes sense, doesn't it? Because isn't the domain all the x's? And in the inverse, it becomes all the y's. In the original, all the y's become all the x's. And finally, we just have to say is the original a function? How about its inverse? No, it's not. Because there's a vertical line segment that's part of it, which means I can draw a vertical line through a whole bunch of points on the inverse. Okay, now that we've done that one, okay. Oh, sorry. Okay. So, if we do mapping notation, I'm actually going to pick 5 points. Pick these 5. You may have picked 5 slightly different ones. Nothing wrong with that. So -4, 3. -1, 0. 0, 2. 1, 0. And 4, 3. Therefore, the inverse points will be 3, -4, 0, -1, 2, 0, 0, 1, 3, 4. So 3, -4 gets me here. 0, -1 gets me here, connect. 2, 0 gets me here, connect. 0, 1 is here, connect. And 3, 4 is here, connect, and I can see my W. Looks like so. Okay. Not necessarily, no. But this one, the invariant point, would be very hard to find from the graph. Why? It's wherever, basically, it's wherever, this is where you got to use the diagonal line. Think of the black diagonal line.
That's when you cross it together. Unless we use that as what it's fractured.
So it would be here, which would be some sort of fraction. I wouldn't ask you the invariant point on this one. Okay. You can figure it out, but it's rather challenging. So, domain and range of the original relation. And I don't even have to look at the diagram if I don't want to. I just take these two the entire, hey, the entire things and flip them. And you do a little jump while you flip it. I don't know why I had to jump when I did that. I am so excited.
Yes, yes. No. What?
Is the original function. The inverse?
Yeah. No. No, I just think that can do that.
Okay. Ladies, one last thing to do.
Oh, I'm so hungry to keep my battery.
What happens
Here we go.
if we are asked to evaluate the inverse of a function? Which means you're given a function as an equation, and you're asked to find the inverse when x is 2. What do you think you'd do?
So.
Inverse it and then plug into.
Yeah.
Yes.
Hey, everyone's saying draw. You already did that?
And plug into.
Whatever.
So what's my first step? Take inverse. Come on. Come on. Yeah, hilarious. Next. Oh, I got 60 extra lines now. Which is the inverse. So I'm going to write it like that. So I've got so this is the original, this is the inverse, this is what I plug 2 into. So F inverse of 2, I plug 2 in here and calculate. 2 plus 2 over 3 gives me 4/3. Can't divide cleanly, leave it as a fraction. Yep. You shouldn't. In the provincial exam, you won't be. If you were given this question, it would be in the non-calculator section. Okay, before going on to the second method, I want to do the next example using the first method. So I want to find the inverse of this one, and then I want to plug 12 in. Next step. No. Times by what? You got to times by y minus 2. Because that's what will cancel out the denominator. You got to multiply by the same thing. Which means you've got to multiply this side by y minus 2. So on the right, you'll just have 1. But what's on the left now? Nope.
times one.
xy minus 2x.
That doesn't make any sense. Why?
Of course it does, because you have to multiply the x by both of these.
Oh. So can we just
Add the two. No, you can't combine these. They're not like terms. I gotta solve for y. Come on, you guys should figure it out.
divide by x?
How about I bring this over to the other side?
Plus
This over to the other side. So I get xy equals 1 plus 2x. And now what? Divide both sides by x. So y is going to equal 1 plus 2x over x. That's the inverse function. That's the inverse of function g. But now we've got to plug 12 in, because we were asked to find what's this value in the inverse when x is 12. So to find g inverse of 12, I do 1 plus 2 times 12 over 12, which gives me a final answer of what? 25 over 12. So you see, it can get a little bit long. But it is a reliable method. Okay, yes, Eva.
Yeah, for sure. Yes, he's nodding. Nodding intensely.
Absolutely.
Are there gonna be like that's one or like two? One. Saturday. What's he saying?
This one here would probably be 3 marks.
Why are you yelling?
Anyway,
Why? Why? Okay.
method 2. Watch carefully.
My brain does not learn. My brain needs food.
Because you can save yourself some time. This is still the original, right? Yes? What's the inverse?
No, X equals 3. Oh, yeah.
Technically, this is in inverse form now, isn't it? So doesn't that mean that I can plug 2 in for the x, since this is in inverse form? So I can plug 2 in here, solve for y.
Plus 2, valid. Plus 2. 4 equals 3. 4 third.
Boom. Mind blown. We're going all the way through and finding the inverse. Like you guys, all of these steps here, these are all the inverse relations. They're all the inverse. This is the original. So I don't necessarily have to go all the way through. I can plug x in here into the inverse, just like we can do it in this one. So we say, okay, y equals 1 over x minus 2, and when I take the inverse, x equals 1 minus y over 2, and now because I'm showing you 2 methods. Because some people prefer one or the other. So now we got to solve for y. Well,
I doubted. Why would you say that?
So I get 12y minus 24 equals 1. I get 12y minus 24 equals 1. 12y equals 25. Y equals 25 over 12.
You are listening a little fast.
Yeah, maybe you should be paying attention. Because a lot, I don't know how many times I've had to say shh this class.
No, don't do it. No, that's just fine. I messed up.
I'll wait until people have finished this. So exercise 1.6, you want to get it done sooner than later. Okay. Friday, we're going to do some questions together. Okay. And you've also got the review exercise for the test, as well as the test outline. If you don't have one of those, they're up here. It looks like a few people haven't taken the outline. Okay. Function is you can't draw a vertical line through more than one point.
Yeah. But can you go, one of you can go like your down. She said, these are from you.
The originals, yes, but what about their inverse?
What you mean? I was thinking kind of. How are you? I think the